Okay, so today I'm going to talk to you about chemical and mechanical digestion of proteins and also the synthesis of new proteins to build muscle. So you, being a college athlete, you're looking to build lean muscle, promote a low body fat percentage, and this is just a little bit of the physiology behind it. So if you look behind me, I've drawn the essential amino acids. So these are the amino acids that the body needs to consume in order to form muscles and promote a lean body. So we have, this is kind of a mnemonic that we have to remember it. So Private Tim Hall. And these are more of the chemical terms. So if whenever you look on the back of a protein powder supplement, these are some of the words you might see. Phenylalanine, valine, threonine, tryptophan, isoleucine, methionine, histidine, arginine, leucine, and lysine. So these are going to be the proteins that your body needs to consume. And then there's also a set of non-essential, which these are the ones that can be manufactured by the body and synthesized internally. So if you look over here for the digestion pathway of proteins, it begins in the mouth with mechanical digestion. Mechanical being chewing, swallowing, biting up the pieces of food into smaller chunks so that it can be transferred down to the esophagus to the digestive organs. So now if you look here, this is a liver, stomach, small intestine. Over here in the blue, you can see that the proteins from food are beginning to be chomped down in our mouth. Then something called chemical digestion will occur in the stomach. So we have hydrochloric acid, which is going to trigger pepsin to be converted to pepsinogen, which is the active form of the zymogen, to start cleaving, which cleaving just means breaking down the amino acids into smaller components. The proteins are denatured, and this needs to occur so that the enzymes can come in and do their job of breaking the proteins down even further so that they can end up into the bloodstream to circulate throughout the body to synthesize new muscles. So again, the proteins are denatured and hydrolyzed. We have a couple other aminopeptidases and endopeptidases, which come in and begin cleaving more in the small intestine. Then we have the intestinal lining, which the brush border at the enterocyte is where the amino acids will be transported through active transport into the bloodstream. So now, the physiology behind this can be a little bit challenging. So I'm going to take you over here to my little flow diagram. There are two processes that we need to be aware of. So that is transamination and oxidative deamination. Transamination is a process that occurs throughout the whole body, and this is where amino acids are being manufactured into new ones. So the easiest way to think about it is you have an amino acid come in. A cycle goes through, the nitrogen group pops off, and it becomes a keto acid to be transformed into a new amino acid. And a good way to think about this is a burger. So a burger, a burger and bun. So we have a lot of different ways we can structure a burger. We can put cheese, we can put tomato, but the bun is going to be its main component. And this is going to be your keto acid. Oxidative deamination, you think about the word deaminate, deamine, taking off the amine group. An amine group is a functional group which formulates the whole component of an amino acid. When you take it off, it is just that keto acid. So that gets formulated, alpha-ketoglutarate turns into alpha-ketoglutamate, which can then be synthesized or be transported to the urea cycle, where a nitrogen group comes off, and it turns, that is where it can be excreted in the urine. So a lot of people have problems with this when they're consuming too much protein because the cycle gets a lot out of whack, and their body is taking the excess glucose and it's going into a cycle where it makes too much glutamate, and then it goes into the glucose cycle, and that is where we get sarcopenia, muscle wasting, glucose overproduction, insulin resistance, fat resistance, metabolic inflexibility, and that is what we want to avoid. So you, being a healthy athlete, need to focus on regulating these two cycles so that you're consuming enough protein, but you're also tapping into the fat stores, and that is the goal of metabolic flexibility.